All right, let's take a look here at the 5.2 study guide. We're starting a new topic called completing the square. This is the second method. You now know how to solve quadratics by factoring, and we're now going to learn to solve quadratics by completing the square. So let's look at our two vocab words for this section. Completing the square is a way to solve quadratic equations. It involves adding a number to both sides of the equation to make one side of a perfect square trinomial, and then the equation can be solved easily by taking the square root of both sides. So what does that mean? I want you to imagine yesterday in class how we were practicing doing something like x plus 3 squared was equal to 25. So it's where you have a perfect square trinomial on one side. We're going to complete the square in order to make a perfect square trinomial, and then the equation can be solved by taking the square root of both sides. So if you remember us doing this yesterday, that's exactly leading us into the steps of completing the square today. Now, vertex form is a way of moving around the equation once we do complete the square to get it into this form, which makes it easily able to be graphable. So the form y equals a x minus h squared plus k, writing a quadratic function, and x squared, a parabola. The vertex is hk, and x equals h is the line of symmetry. So imagine a straight line drawn directly through the vertex on each of these, and that's your line of symmetry. We abbreviate it as LOS. It's the line that cuts your parabola exactly in half so that it's like a mirror image if I reflected one onto the other. And over here, this is just a quick reminder of what is the other form we've been focusing on so far, standard form, ax squared plus bx plus c. So this is the form we've been exposed to so far. This is the new form we're going to start to see today and practice throughout this unit. So let's fill in the blanks to complete this list. Completing the square is a method for solving quadratic equations. Quadratic being x squareds. You add a number to both sides of an equation to make one side a perfect square trinomial. And again, what is a perfect square trinomial? It's something like x squared plus 14x plus 49, where if I factored that, what times what equals 49 and adds up to that middle term of 14? 7 and 7, oh, it's the same number because this is a perfect square trinomial. 7 squared makes 49. So we can write the factors together as x plus 7 squared. So you add a number to both sides of an equation to make one side into a perfect square trinomial. All right, to complete the square for a quadratic in standard form, ax squared plus bx plus c, when your a equals 1, invisible 1 in front, you're going to add c to both sides. Now, how do I get that c value? I have to do some b work to get the c. So this little formula that we started seeing in our homework last night, which is b, let's use a different color. Going to be b over 2 squared. You're taking the middle term, you're cutting it in half, and you're squaring it. So this is like the little formula that we're going to use in order to complete all these squares. Notice it's already ready here. So what is my b? My b is right here in the middle, meaning the middle term of ax squared plus bx plus c. So the b is 6. So we're going to do 6. Oh, I do not like this color. We're going to do 6 divided by 2. and we're going to square it. So that gives us 3 squared. 3 times 3 is just 9. So completing the square means adding 9, but I can't just arbitrarily add 9 only to one side of the equation. If I add 9 to one side, I have to add 9 to the other side as well to balance. So let's go complete the square on this one using the same steps. On this one, I have a 10 as my middle term. So I'm going to say 10 divided by 2, split that 10 in half, and square it, which gives me 5 squared, which gives me 25. So I'll be adding 25 to both sides of the equation on this one. I just completed the square by adding 25 to both sides. So let's go through a full problem. We're going to give you something in standard form. You need to get the constant, the negative 14, and move it over. We're going to use inverse operations to isolate the constant. Well, guess what? Inverse operations means what's the opposite of minusing 14? We're going to add 14 to both sides of the equation. Adding 14 brings that 14 to the right-hand side of the equation, and left on the other side now is x squared plus 8x. Now we have this nice opening to complete the square. So let's go do our b work. b over 2, and we're going to square it. This time my b is an 8, so we're going to go 8 over 2 squared, which will be 4 squared. And 4 times 4 is just 16. If I add 16 to one side, I have to add 16 to the other side. Now to get from this step to the factors, some of you can already see this 4 and you can see the x plus 4 factors. If you haven't gotten there yet, let's do the regular way we factored this. So what times what makes 16 and adds up to 8? Oh yeah, it's 4 and 4. This is the x plus 4 factors. But how would I know that otherwise? Remember, we just took the 8 and divided by 4. We took the 8 and divided by 2, and so 8 divided by 2 gave us 4, and that 4 is what's being squared, so it's the x plus 4 squared factors. This is equal to 30 because 14 plus 16 equals 30. Now it looks like something we've been practicing for the last 2 days. Now we can square root both sides to solve. When I take the square root of x plus 4 squared, it just leaves me x plus 4. When I take the square root of 30, I'm like, wait a second, that's not a perfect square. So let's see if we can simplify the 30. There's not a 4 that divides in, there's not a 9 that divides in, 16 doesn't divide in. So root 30 is actually just already done. So I'm going to minus 4 from both sides, and I would get x is equal to negative 4 plus or minus root 30. But they want us to write the answer out in 2 different ways. So we're going to write negative 4 plus root 30. That's my first root. And then we're going to write negative 4 minus root 30. We just took these 2 and split them up to give our final answers. All right, let's go through a whole nother example following all the steps. Step number 1, using those inverse operations to move the 12 over. We now have a 12 on the right-hand side, and it moved over from here. Next, we want to isolate that x. I want to complete the square on 1x, not 3 x's. So let's get rid of this 3. Divide everything by 3, and that leaves us x squared plus 10x equal to 4. Now we make space to complete the square. I go do my b work. It's half of that middle term, and squaring it. So we take the 10, divide it by 2, and square it. That gives us 5 squared. That gives us 25 that we're adding to both sides. If I add to one side, I have to add the same thing to the other side to balance. So what are my 2 factors for this perfect square trinomial? Remember that you can do the x, put the 25 on top 10. You'll notice it's 5 and 5. Or some of you are already seeing this pattern of this 5 right here, it's your factor. Notice that 4 plus 25 on the end right here became 29. Finally, we take the square root of both sides. Square root of x plus 5 squared just gives me x plus 5. Square root of 29 cannot be reduced, so we just write plus or minus square root of 29. We subtract 5 from both sides to solve, and x is equal to negative 5 plus root 29 and negative 5 minus root 29. Notice they're breaking up those two roots. And those are my two solutions, my two roots, my two answers. Okay, we're now moving on to a new form of our parabola from that definition we did up at the top, where y is equal to ax minus h squared plus k. Okay, it's the point where the curve of the parabola changes direction. Okay, so what do I mean by changing direction? I mean, picture that you have a parabola, a U-shaped graph, and the vertex is the point where the curve changes. So picture down here where the graph is going down, 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 but then it's going up, 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 up. This is your vertex, also known as a minimum of the graph. It's the point where it changes direction. You could also have an upside down parabola. That's kind of pointy. It shouldn't really be pointy. And that also could have a vertex as a maximum, that highest point, because that's where it changes direction as well. The parabola's line of symmetry passes right through the vertex. So if your vertex is HK, okay, right here and right here, then your line of symmetry goes straight through H. Remember that an x equals line is a straight up and down vertical line. So if your vertex was at 3, 9, your line of symmetry would go through x equals 3. The halfway point between the parabola's two x-intercepts. Oh, here comes this conversation about x-intercepts again. It's finally their day. So picture a line of symmetry being dashed straight through this, and it's the exact halfway point in the parabola between the two x-intercepts. Okay, label the vertex and the x-intercepts on each graph. So right here and right here, we have x-intercepts, or the places where we touch on the x-axis. And then right here, we have the vertex. On this graph, do you see it? Here we have a vertex. And here we have the x-intercepts. The vertex is the lowest or minimum point on a graph of a parabola that opens up. The vertex is the lowest or minimum point on a parabola that opens upwards, like a smile. The vertex is the maximum or highest point on a graph that opens down, an unhappy smile, an unsmiling face. All right, the vertex form of a parabola like this, where HK is the vertex, and the line of symmetry goes straight through x equals h. If the parabola opens up, then the vertex is a minimum or a lowest point. If the parabola opens down, then the vertex is a maximum. Complete the square and rewrite this in vertex form. So again, we've got this 4 over on the wrong side. So we're going to go ahead and subtract the 4 from both sides, bringing it over with the y. And now we open up and make space for completing the square. Again, I'm going to go do the b work here. 6 divided by 2 squared is equal to 3 squared, which is equal to 9. So to complete the square, I'm going to be adding 9 to both sides. Notice that the x squared plus 6x plus 9 turns into the x plus 3 factors, and that the negative 4 plus 9 turns into 5. Now to isolate y, you get it into vertex form. So our last step is just moving that 5 over, subtracting 5 from both sides. So we get x plus 3 squared plus negative 5 as our final answer. Now, what's my vertex of this parabola here? So remember that it's y equals a x minus h squared plus k. So my vertex is the h and the k. Notice there's a negative in this equation, so that's going to make the value for x always the opposite of the value of the x on the graph. Just like point slope, just like absolute value, just like all the examples we've seen so far back at the beginning of the school year. So if my hk is a 3, 5, then it's going to make it negative 3 in the equation. So check this out. X plus 3 would have to be x minus a negative 3 as your real x value so that it turns into an x plus 3. So your vertex is at negative 3, negative 5, and I pull that straight out of the equation. Negative 3, negative 5 is my vertex. Okay, given this vertex form, let's practice finding the zeros. So we're going to start by adding, actually take a step back. To find the zeros, we need to set it equal to 0. All right, so we're going to start by adding 5 to both sides. And that leaves us these factors of x minus 2 and 5. Now it's in a position for us to just do the square root of both sides. Square root of anything squared is just that same anything. And this gives us plus or minus root 5. There's no simplifying needed there. Add 2 to both sides, and we get an answer of 2 plus or minus root 5. And over here they want us to break it out. 2 plus root 5 and 2 minus root 5. And those are our 2 answers. That's how we go from vertex form and solving. And that's the end of our study guide.